Believe House. Oh, today we're going to look at special quadratics. These quadratics sit at the cool kid table at lunch, and they don't want anyone else sitting with them. Yeah, you know the type. They're just special. So a magical whiteboard appears, and let's get rocking and rolling on these special quadratics. Okay, so the first problem here. Okay, we got x plus 4 times x minus 4. Let's do our arches. Remember how we did the arches. So we're going to do the arches. Let's draw our 3 blanks. Okay, and x, remember, first, x times x is x squared. Last, positive 4 times negative 4 is negative 16. And then in the inside arch, we get a plus 4x. And in the outside arch, we get a minus 4x. Okay? So the arch numbers are opposite, aren't they? They're going to cancel out, right? So the only thing left is just x squared minus 16. Okay? Wow. These, like I said, these are special quadratics. Next week, or later this week when we graph, these will have special graphs. And they let all of the other graphs know it, okay? Like the homecoming queen. Oh, so let's keep going. Okay, right here, 5x minus 1, 5x plus 1. Okay, so we're going to draw our arches. Remember, we're going to do the first times the first. That's not the first. The first times the first will be 5x times 5x. That's 25x squared. A positive 1 times a negative 1 is a negative 1. And then the outside arch, or the inside arch will be plus 5x. The outside arch will be minus 5x. It cancels, doesn't it? So the answer is just going to be 25x squared minus 1. Now then, notice what's happening here. The first term and the last term are perfect square roots, aren't they? Okay, that's because the first terms are the same and the last terms are the same. The middle term cancels because the parentheses have different signs. Let's go to this one. Let's let the board clear up. Okay, draw your arches. These are our first terms. So 2a times 2a is 4a squared. These are our last terms. 3b times 3b, a negative 3b, is a negative 9b squared. And then the inside arch is plus 6ab, and the outside arch is minus 6ab. Remember, sign, number, letter, exponent, right? And so the 6ab's cancel out, don't they? Okay, so our answer is just going to be 4a squared minus 9b squared. Okay, piece of cake there. So they're both perfect squares, right? Okay, now then let's keep going. To factor a difference of squares, and remember, this is called a difference of squares, okay? This is so special it's on your formula chart. A difference of squares means that the parentheses are exactly the same, but the signs are different, okay? So the way you would factor this, let's go to here, square root, okay? The square root of a squared is a, the square root of b is b. You draw your parentheses, you put AB in both parentheses, and remember the signs will be opposite. That's all you have to do. So if the first term and last, if there's no B term, and the first term and last terms are perfect squares, it's always going to be a difference of squares. So let's go down. I'm just going to do a few of these for you. On the first one, a squared is a, let's write our perfect squares to the left. Okay, so the perfect squares are 1, 4, 9, 16, 25, 36. We'll go down to 10. Then 49, 64, 81, and 100, right? And I don't think there's any over 100. No, there's none over 100. So if it's one of these numbers, it's a perfect square. Okay, so let's zoom back in. Right, just draw little bitty square root symbols. The square root of a squared is a. The square root, don't worry about the negative, the square root of 4 is 2. So I'm going to draw 2 parentheses, put a and 2 in both parentheses, make 1 plus and 1 minus. Doesn't matter the order. Okay? Piece of cake. This is simple, simple, simple. And it's called the difference of squares. Later this week when we start graphing these are very special parabolas. That's why they sit at the cool kid table. Let's go down to 7. You can square root, square root. The square root of 9b squared. The square root of 9 is 3, and b squared is b. So we got 3b, and the square root of 100 is 10. So I'm going to draw 2 parentheses and put 3b and 10 in both parentheses. Since it's a difference of squares, the first, you can make them in any order. One's positive, one's negative. Oh, and we'll do one more together. Let's do I'll do 11 and 12 with you. 4 and 25 are both perfect squares. So we're going to square root, square root. The square root of 4 is 2h, right it below. The square root of 25g squared is 5g. And then you draw your 2 parentheses. You put 2h and 5g in both parentheses. And one's positive, one's negative. Piece of cake. Oh, 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 oh. And lastly, I'll do one more with you because this is kind of freaky. Okay, so we have xy squared minus 1. So the square root of x squared y squared is just going to be xy. xy times xy would be x squared y squared. So I'm going to put a little bitty xy and square root of 1's 1. So draw your 2 parentheses. xy and 1, xy and 1, and 1's plus and 1's minus. Oh, 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 oh. Okay, this is going to be a piece of cake. You should lickety-split go through this. Remember, these are called difference of squares. So it's only 2 terms, and you don't have that middle term in the middle because it cancels out when you do the full. The outside and the inside arch are opposite, and they cancel out. Now then, the application problem of this. Okay, this is on the back of your paper. Okay, remember, area equals length times width. If I know my length and width, I'm going to multiply. If I know the area and the length or the area and the width, I will divide, okay? Okay, so let's go to this one. The length is this, the width is this. I'm not going to do these problems for you. You're just going to do x plus 5 times 2x minus 3. So the area is equal to the length times the width. So you'll draw your 3 blanks and you'll draw your arches. First term, outside, inside, and last term, right? And you'll multiply and get them out, okay? Zoomed in too much. Okay, a square, if you look at a square, the length of the length is the same, right? Okay, so we're going to take this and we're going to do 2x plus 4 times 2x plus 4. And you're going to multiply those out, okay? First, outside, inside, and last, right? Just multiply them out and get the answer, okay? Now then, really quickly, the area of a rectangular swimming pool is this, and the length is this. What would the width be? So we need to factor this. So 10x squared minus 19x minus 15. Draw your 2 parentheses. You're going to take the 10 and 15 and multiply and get 150. And let's get this. We need the factors of 150 that subtract to give us 19. So I'm going to go to the calculator. I'm going to go to graphs. So home button. I'm going to click B for graphs. And then I want the factors of 150, right? So 150 divided by x. Hit enter. Then hit Control T. And I want those factors to subtract and give me 19, don't I? So I'm going to keep going down. I want to subtract and get that right there. The 6 and the 25. 25 minus 6 is 19 in it. Okay, so those are going to be the ones that work, aren't they? Okay, so I'm going to go back and I'm going to use 25 and 6. So I'm going to put 6 and 25. The 25 will be negative and the 6 needs to be a plus to get the negative 19, right? I'm going to put 10x on the bottom and I'm going to let you finish that up, okay? Going down to here, which one is a factor of this? So we're going to write down 2x squared plus x minus 3, and we need to get the factors. This is probably what you'll see on your STAR test. They're not going to give you both of them. Okay, so you're going to do 2 times 3 and get 6. We want to subtract and get 1, and that's 2 times 3, right? Then put 2x on the bottom. See if you can simplify, get it out, okay? You can finish it up. Okay, the volume is this, so we're going to take 3x squared plus 21x minus 24. We need to factor that. These are going to be the factors over here, okay? Notice I could take a 3 out of here, doesn't it? It has a GCF, doesn't it? Plus 7x minus 8. Now then, I can factor this. I need the factors of 8. Then subtract and give me 7. I will let you finish that up. Have a wonderful, wonderful day. I hope you enjoyed this. This is one of the harder things we're doing in this year. This factoring is tough. If you're going into higher level math and engineering, this is the base level of what you'll be doing with the calculus and the engineering. Have a wonderful, wonderful day. Remember, you are amazing. You are created to do wonderful things, and you are awesome.